This video explains clearly about the various methods of solving systems of linear equations. So in this video, we are going to see the different methods. The first method is the graphing method. Second one is the substitution method. Third, the elimination method. Number 4 is the determinant method, or called the Cramer's rule. Number 5, the reduced row echelon form, or it is called the Gauss elimination method. Number 6 is the graphing calculator to find the reduced row echelon form. In order to understand this graphing method, let us graph a system y equal to 0.5x plus 2, y equal to negative 2x minus 3. So we can graph these two lines and get the point of intersection of those two. That will give you the solution to this system. So this is useful when we need a rough answer, or when we are pretty sure that the intersection happens at an integer coordinate. Suppose if this intersection is not a whole number, if it is a decimal or a irrational number, then the graphing method will not be of much use to us. Here in this case, the solution set will be negative 2, 1. Next, let us try to find the substitution method. Now, when you do the substitution method, you try to solve one of the equation in terms of a variable. So here the second equation is obtained using the value of x. Y is written as in terms of x. Substitute that in the first equation. So you'll get an equation all in terms of just one variable. Here we are getting in terms of just a variable in terms of x, and we get x is equal to 2. Substituting x equal to 2 in the first equation, what we took, y equals 19 minus 7x, we get the value for y as 5. So this solution is 2, 5. First, solve one linear equation for y in terms of x. That is our first step. Then substitute that expression for y in the other equation, solve for x. Plug this value in any one of these equations to get the value for y. The third method is the elimination method. Under the elimination method, when we are trying to solve, we have to make either the coefficient of x or the coefficient of y to be the same. Then add or subtract to eliminate one variable. Get the value of one variable and then substitute that in any one of those equations to get the solution. So this is called linear combination method or elimination method. Here we are adding or subtracting a multiple of one equation to form the other in such a way that either the x term or y term will get cancelled out. Then you are trying to solve for x or y, whichever is left, and substitute it back to get the other value. And the next method is the Cramer's method or the determinant method. In this, let's take the general case. Suppose if you have a system of equation in terms of two variables, then we can write that in the matrix form, and we can take the coefficient matrix and find the determinant of it. That will become the denominator of those variables. And the numerators will be the same coefficient matrix, but the corresponding columns will be replaced by the constant matrix. The constant here is C1, C2. So in the case of x, that coefficient A1, A2 will be changed into C1, C2. And for y, the coefficient B1, B2 will be changed into C1, C2. So we know that the value of the determinant is the product of the leading diagonal minus the product of the other diagonal. Or we can make use of the graphing calculator to get this result. So if I'm trying to solve for this equation 12x plus 3y equal to 15 and 2x minus 3y equal to 13, my x will be, the determinant of the coefficient will be 12, 3, 2, negative 3, and the numerator, the coefficient 12 and 2 has to be replaced by 15 and 13. Then the coefficient of y is 3, negative 3, simplifying with that as 2. And the same way you can find the value for y by taking delta y by delta dy by d. In this case, the solution is 2, negative 3. We can also make use of the Gauss Jordan's elimination method. But if you're doing it by hand, it is a rigorous process. The first step is to convert this matrix, and we have to rewrite this as an augmented matrix with the coefficient and the constant. And we are repeatedly using the row operation or the column operation and trying to make this as an identity matrix. So we add, subtract, multiply, do all sorts of matrix algebra, and then try to write that as the identity matrix, and then the last column will be the answer for the coefficients x and y. So you are applying elementary row operations to the matrix to obtain the row equivalent or the row echelon form. And this method of elimination continues until a reduced row echelon form is obtained. This demonstration we can see here in this page, but sometimes it will be a little tedious. So instead of doing this using Gauss Jordan's elimination, we can also use a graphing calculator to do the same reduced row form and get the final answer. For example, if I'm using my TI 83 or 84 for this 3 by 3 matrix A, I need an augmented matrix with the coefficient and the constant. So we have to select, edit the matrix. 3 by 4 matrix has to be entered in my calculator, and then select your matrix math. In that, find the reduced row echelon form. Get the reduced row echelon form of the matrix. That gives me 1, 0, 0, 0, 1, 0, 0, 0, 1, and the last column is negative 7/8, 3/4, and 9/8. So those are the values of x, y, z. X will be negative 7/8, y is 3/4, and z is 9/8. Hence, the solution for this system will be negative 7 by 8, 3 by 4, and 9 by 8. So in this video, we saw various methods of solving systems of linear equation. We saw graphing method, we saw the substitution method, elimination method, Cramer's method or the determinant method, Gauss Jordan's method or the reduced row echelon form, and finally we used our TI 83 and 84 to get the values very quickly, and we are confident with that answer. So thank you for watching this video. Hope this video was helpful in understanding the various methods of solving systems of linear equation. Thank you for listening, and thank you for watching.